So we have this CSES problem set given the problem maximum subarray sum. And the question simply states that given an array of n integers, your task is to find the maximum sum of the values in contiguous non-empty subarray. So initially we'll be given the size of the array as 8, and then we'll be given 8 elements of the array. And what we need to find is print out the integer, the maximum subarray sum. So we need to iterate over the array and we need to find the maximum subarray sum that we can get. So if we add all the numbers from 3 all the way up to 3, and this will give a sum of 9, which is maximum. So this will be our answer. Now the initial glance at this kind of problem might look really complicated, as you might think of trying the brute force way would be to try and find out all the possible combinations of subarray and calculating the sum and finding the maximum. But there is a specific algorithm designed to solve this kind of problem. The algorithm was given by Joseph B. Kadane in 1984. The algorithm is Kadane's algorithm. So basically, anytime you are given an array and you need to find a specific length of subarray or a sum of subarray, or maximizing the sum of subarray or minimizing it. Anytime you are given an array and you need to find a specific subarray, right? Subarray given some condition, we will use Kadane algorithm, right? Kadane algo. Now using Kadane algorithm, we will just iterate over one time. We will iterate over the array and we will be able to find the maximum subarray sum. It will take a time complexity of ON, right? Just one iteration over the array will give us the maximum sum of the array, maximum subarray sum, right? So if you write out the problem, we had -1, 3, -2, 5, 3, -5, 2, and 2, right? Now all we have to do is maintain two variables. One, let's say we call it temp sum, and other let's call it maxi sum. Maxi sum will be our final answer, and we are maintaining two variables, right? So initially what we will do is we'll assume the first index value to be the maximum subarray sum that we need. So we'll take -1, right? So we'll take -1 as the first subarray sum and assign -1 to temp sum and maxi sum, right? Now we'll start our iteration from 3 onwards, from the first index all the way up to the last index. So we'll compare 3 with this subarray sum, right? So 3 and 3 plus -1 gives us 2, and we'll find the maximum of it. Clearly the maximum is 3. So our new current subarray sum, maximum subarray sum is 3, right? So we'll assign it to temp, and here we'll maintain, let's say, the maxi. So the current maximum subarray sum up till the first index 0 and first index is 3. So we'll change the temp subarray sum from -1 to 3, and whenever the temp sum is greater than maxi sum, we'll update the maxi sum. So it will go from -1 to 3. So this is our maxi sum subarray and this is our temp sum subarray. Again we move the pointer to -2. So we'll again find the maximum of -2 and this subarray, right? -2 and 3 plus -2 gives us 1. So we'll have the 1. We'll assign 1 to temp sum. Simply now temp we have this subarray as 1, right? As temp sum we have 1, and 1 is not greater than maxi sum. We'll not update the maxi sum. Move the pointer to the next variable. We have 5, right? We will compare 5 with this subarray. We are taking account of this subarray and 5, right? And 5. Now clearly 5 plus this was 1, so 5 plus 1, 6. We'll trying to figure out the maximum of 5 and 6 will give us 6. So we will update the temp sum value from 1 to 6. So our current temp sum is 6, right? This is 6. And as temp sum is greater than maxi sum, So we'll update the value of maximum from 3 to 6, correct? So currently our maximum, the maximum that we are maintaining, the maximum contiguous sum of subarray is 6. This is 6, right? And the temp sum is also 6. Up till this 5, our maximum is 6. So we go to the next index as 3. So we compare again, the same pattern goes on and on. So again we compare 3. Okay, let me erase this. Again we compare 3 with this subarray. So this is 3 and this was 6, 7, 8, 9. So we compare the maximum of 3 and 9, which gives us 9. So update the value of temp sum from 6 to 9. So currently our maximum temp sum subarray is 9 up till this iteration. As temp sum is greater than maxi sum, so we'll update the maxi sum from 6 to 9. Again move to again we update the maxi also. So this is our maxi subarray till this point. Now we move to -5. Again we'll do the same thing. We move to -5. Compare this -5. Compare this -5 with this subarray. This is -5 and this is 9 plus -5 is 5, 6, 7, 8, 9, 4. This is 4. Clearly 4 is greater. So we'll update the temp sum from 9 to 4. Right? Now clearly 4 is not greater than maxi sum. So we found out that maximum of -5 and 4 is 4. Now 4 is not greater than maxi sum. So we'll not update the maxi sum. Maxi sum is still 9. See, maxi sum is still, let me change the color. Maxi sum is still 9, right? All we did was we updated the value and we're trying to check if there are any possibilities of finding even greater than 9, right? Maxi sum is 9 and we are trying to find possibilities any number greater than 9. Still we have 4, right? So we updated the value of temp to be 4. Move to the next number. What we will do is we will compare 2 with 4, 5, 6. We'll compare 2 with this one. 4, 5, 6. This is 6 and this is 2. And maximum of 6 and 2 will give us 6. So we'll update the temp sum from 4 to 6. So currently this is our maximum, right? Yeah, this is our maximum. And at end we'll compare 2 with 6 plus 2, which is 8. So we'll comparing 2 with 6 plus 2, this array, right? This is 2 and this is 8. So our maximum of this 6 plus 2 and 8 will be 8. We'll update the temp sum as 8. Still temp sum is less than maxi sum, so we'll not update the maxi sum value. Now at the end, as we have completed the iteration, at the end we will return the maxi sum. This will be our answer, right? Clearly we found the maximum sum of the subarray in an array using Kadane algorithm. Now if we write out the code would be really simple. What we will do is, what is the first thing that we are doing is initializing temp sum and maxi sum to -1. -1 why? Because it was the 0th index of the array. So we'll write this. Let me change the color. So temp sum to be ar0 and similarly maxi sum to be ar0. Then what we are doing? Then we are iterating from the first index. One after the other to all the way up to the last index. So we'll run a for loop for int I is equals to 0. Sorry, I equals to 1 from the first index all the way up to the I less than ar dot size I plus plus. Then what we are doing is we are in every single element. Let's say we are at ar1, right? What we are doing is we are comparing ar1 with the previous temp sum value plus ar1, and we are finding out the maximum and assigning it to temp sum. What we are doing is we are going at ar comparing this ar value with the previously temp sum plus ar. Previously we had temp sum, right? Temp sum, adding it to array. So let's say we have this array, right? let's say we have this array and previously our temp sum was this value, let's say the value to be 12, and we are currently at the value to be -4, right? we are comparing we are comparing this -4 with temp sum plus -4 and assigning the maximum of these two value into temp sum, right? So we are taking the maximum of this two value using the max function and assigning to this temp sum, again updating the temp sum value. And after every update, what we are checking is if temp sum if temp sum is anyway greater than the maxi sum, right? If temp sum is anyway greater than maxi sum, what we will do is we'll update the maxi sum to be temp sum, and that's it. This three line, actually all this three line is the cadence algorithm by which we will be able to find the maximum sum of the subarray in a in an array. So if you look at the code, if you look at this code to calculate the time and space complexity, what we have done is in the main function we have called this max subarray function, and we are writing this cadence algorithm that I told you right now. So first step was to take the input, which would take an time complexity of on n being the number of elements in an array. Now calling this function, we are initializing maxi sum to be our answer, and temp sum to be the temporary subarray sum as ar0, and from index I equals to 1 all the way up to ar size we are iterating over it, right? Now this runs for a time complexity of on minus 1, right? If n is very high, right, for a worst case scenario, we can assume it to be almost on, so our time complexity will be 2 times on. And for the space complexity, we are just assuming only one array, so our space complexity will be on, right? Space complexity will be on and time complexity will be 2 times on.